How do we use method of group averages when the dataset has odd numbered data points? Learn it here in Numerical Solutions to see problems. The approximate approach of curve fitting needs to minimize the errors, if not zero it out. And with this method, the concept is to have the positive errors balance out with the negative errors so they can cancel out. The definite algorithm of group averages starts by dividing the dataset into two tables. In case there is an excess pair of coordinates, the first table would absorb it. Next is to take the summation of the x and y values in order to solve the average of each variable. Having an average x and y values, place them into the slope-intercept format of a linear function. Then through simultaneous equations, solve for a and b. Then again, these variables are placed into the required function. Given the data set of 9 coordinates, we are to look for the function of the best fit line. Since there is an excess in the division of data points, the first table will include 5, and the second table will have the rest. Place the coordinates in two separate tables and compute for the total. X from the first table add to 6, and Y has 62.19. X is 8.4, and Y is 79.145 from the second table. Now for the average. 6 divided by 5 is 1.2, and 62.19 over 5 is 12.438. For the next pair, x is 8.4 over 4, giving 2.1, and y has 79.145 divided by 4 to have 19.78625. Having known the averages, we can generate the two equations required for the function. The first is 12.438 as equal to 1.2a plus b. The second equation is 19.78625 as equal to 2.1a plus b. With the equations already identified from tables 1 and 2, you can use the function for simultaneous equations in your calculator, or just simply subtract the equations, resulting to negative 7.34825 as equated to negative 0.9a, where a is then solved as 8.1647. Substitute a into any of the functions. Say we use the function from table 1, making the equation 12.438 as equal to 1.2 times 8.1647 plus b. This is simplified as b equal to 2.64036. Finally, place these variables into the best fit line function as y is equal to 8.1647x plus 2.6404. In case we are also to take the function of the quadratic curve of the same dataset, let's say that we want the curve to pass through the point 1.8, 17.155. With the same start, create a table for the first group containing x from 0.8 to 1.6. Capital X is also taken as x plus 1.8. And capital Y is the ratio of y minus 17.155 with x minus 1.8. These can be derived as shown in the previous video, but through patterns, one can easily figure out how to come up with these short functions. Now complete the column for capital X, where we take 0.8 plus 1.8 as 2.6, and do the same with the rest of the column. Capital Y is initially 10.015 minus 17.155 all over 0.8 minus 1.8, which is 7.14. And this will be done with the same ratio for the rest of the column. With the completed columns, the summation of capital X is 15, and that of Y is 41.92542. Their average is solved as for X as 15 over 5, which is 3. Then, 41.92542 over 5 as 8.38508. The function for this table is then 8.38508 as equal to 3a plus b. From the second table, we have x values of 1.8 up to 2.4. Capital X for the first point is 1.8 plus another 1.8, which is 3.6. Do the same computation for the rest of the column. Capital Y is 17.155 minus 17.155 all over 1.8 less 1.8, which is undefined, but is simplified as 0. The rest of the column is still computed with the same function. Now take the total of each column, having 15.6 for capital X and 27.475 for capital Y, where the average is then 15.6 divided by 4 giving 3.9. Average Y is 27.475 over 4, which is 6.86875. Take note that the average for the second table is solved by dividing the total by 4 and not 5, as the previous table. The function is then 6.86875 is equal to 3.9a plus b. Take the two equations generated from the two tables and look for the variables a and b using simultaneous equations. That is by subtracting the two, which results to 1.51633 as equal to negative 0.9a, and a is solved as negative 1.68481. Use this value of a into any of the functions, for example that from table 1, which then becomes 8.38508 as equal to 3 times negative 1.68481 plus b, and b turns out as 13.43951. Two of the three unknowns are already identified. Next is to look for c, and that is through the quadratic equation, where we plug in x and y of the coordinate we are interested in, and have 17.155 as equal to a times 1.8 squared plus b times 1.8 plus c. If we place the computed values of a and b from earlier, we get 17.155 as equal to negative 1.68481 with 1.8 squared, plus 13.43951 times 1.8 plus c, where c is then negative 1.57733. With a, b, and c already found, the best fit quadratic curve is then revealed as negative 1.68481 x squared plus 13.43951x minus 1.57733. This time, let's take the function of the best fit exponential curve of the dataset. From the previous video, it was shown that for this procedure, an additional column is necessary to place logarithm of y. So with the first table of x from 0.8 to 1.6, fill the third column with the logarithm of 10.015, which is 1.00065, all the way through the other y values. Then take the total of x and capital Y. X is 0.8 plus 1 plus 1.2 plus 1.4 plus 1.6, which turns out as 6. And capital Y is 5.45083. Their average is taken by dividing the total by 5, giving x as 1.2 and y as 1.09017. These values provide the first equation of 1.09017 as equal to 1.2a plus b. For the second table, do the same with x of 1.8 to 2.4. Logarithm of y of 17.155 is 1.23439 and so on. Take the summation of values, where x is 8.4 and y is 5.17805. The average is then taken when the total is divided by 4, giving x of 2.1 and y as 1.29451. So the equation is 1.29451 as equal to 2.1a plus b. Identifying the two equations, solve simultaneously by subtracting them, making negative 0.20435 as equal to negative 0.9a, where a is computed as 0.22706. This is capital A, but what we need is its transform exponent, or the small letter a, solved with e raised to value of 0.22706, making a as 1.25491. Solve for b using any equation, say that from table 1, making 1.09017 as equal to 1.2 of 0.22706 plus b, where capital B is 0.8177, and small b is solved with e raised to 0.8177, giving 2.26528. So the exponential curve for the dataset is y is equal to 1.25491 raised to x times 2.26528.